Greetings. Hello. Welcome. So let's talk about the integration of sine squared x dx, or better yet, let's change it to the integral of sine squared t dt. This one will work nicely. So in this video, I'll be talking about how to integrate sine squared x or t, whichever variable you'd like to put them. Alright, so to do this, there is need to know a special set of identities, especially the double angle identities. Sine A plus B is equal to sine A cos B plus sine B cos A. Just correct that quickly. Sine B cos A. Okay, this is just one of them. Another double identity is A minus B is equal to sine A cos B minus sine B cos A. Okay, so let's look at another one. So these are the sine double identities. Let's also look at the cos. We have cos A plus B is equal to cos A cos B minus sine A sine B. Another one is cos A minus cos A cos B plus sine A sine B. You'll notice that the signs vary when it comes to the cos one. Okay. Now from these double angle identities, we can create very nice identities that we can always use to simplify any integral, any expression that is similar to sine squared t, or it could be a product of sine and cosine. So we can use these to simplify, so the integration can be carried out easily. So to do that, we create simplified identities which we could use for an overcomplicated case. Okay, so from here what I'll do is let me name this. Name this equation 1, equation 2, equation 3, equation 4. Okay. I'll add equation 1 and 2 to come up with a new identity. Okay. So when we do that, becomes sine A plus B plus sine A minus B all of this, because what I did there was I added this one and that one. That's what I got. That's what I have here. Okay. All right. On the other side, I'll add this one, this one, and this one, that one, and this one. So this and this are the same. It's sine A cos B. It's sine A cos B. That is also sine A cos B. If we add those, it becomes 2 sine A cos B. And the following are also the same. Sine B cos A, sine B cos A. If we add this, but then there's a negative here, they'll add up to 0. So it's the same thing as sine B cos A minus sine B cos A, which gives us 0. From here, I can make sine A cos B subject of the formula. How we do that is just divide everywhere. Divide by 2, divide by 2. Then we'll have sine A cos B is equal to sine A plus B plus sine A minus B. And all of that is divided by 2. So this is a very nice equation that one can use to simplify a case. What case would that be? Let's say you had an integral of a product of sine A and cos B. You would then replace all of this with that to simplify your integration. Okay, so when we add it, we get that. Let's subtract the two equations and see what else we can obtain. Okay, this was addition. Now let's look at subtraction. What do we get? If we subtract the very same equations, it will be sine A plus B minus sine A minus B. Okay, we'll have sine A plus B minus sine A minus B, and all of these will be equal to sine A cos B minus sine A cos B. That gives us 0, 0, and sine B cos A minus sine B cos A. Minus and minus becomes positive, so it becomes plus sine B cos A. Very nice. And all of this, what's going on here? Sine B cos, sine B cos A plus sine B cos A. That becomes 2. Plus 2 sine B cos A. Okay, from here can make sine B cos A subject of the formula, and you know how to do that. We just divide everywhere by 2. Divide everywhere by 2. Then this becomes sine A plus B minus sine A minus B all over 2. And this is another very good identity that can help in simplifying. Sorry about that. that can help in simplifying, yes, an integral with the product of sine b and cos a. If you're integrating a product, you can always use this to help you. So, very nice questions. And we do the same. These are very, very crucial equations. Very, very crucial identities, okay? And then we do the same for, we do the same for cos. We add it. Let's add them and see what we get. We get cos, so we're adding equation 3 and equation 4. So we get cos A plus B plus cos A minus B, and all of this will be equal to this and this are the same. Therefore, if we add them, we get 2 cos A cos B minus sine A sine B plus sine A sine B. If we add that, we get 0. Make cos A cos B subject of the formula. What do we get? Divide every by 2, we get cos A cos B. All of this is equal to cos A plus B plus cos A minus B, and all of that is divided by 2. So this is a nice one. This is a nice one. Because if you had in the integral sign a product of cos A and cos B, let's say A was equal to B, this will become cos squared A. It will become cos A multiplied by cos A, which is the same thing as cos squared A, right? And you could easily replace this with this expression here. Very nice. Okay, so this is what we get from adding. What do we get if we subtract? Okay, if we subtract these guys, what do we get? So as always, on the left side we'll have cos A plus B minus cos A minus B. All of this is equal to, if we subtract cos A minus cos A cos B, gives us 0. If we subtract those ones, becomes minus sine A sine B minus sine A sine B. So we'll have minus 2 sine A sine B, which looks very, very useful in our case. So this will become, if we make sine A sine B subject of the formula, we'll have sine A sine B is equal to, we'll divide by minus 2, divide by minus 2. So this becomes sine A sine B is equal to cos A plus B minus cos A minus B. All this over minus 2, which simplifies to cos a minus b minus cos a plus b. So when we just divided the what, the numerator by -1. Okay, cool. So this, okay, let me write it down here. Sin b is equal to cos a minus b minus cos a plus b all over 2. Now this expression is useful to us right now. Okay, let's look at what we have. What do we have? We sine squared t, that's the expression we want to integrate. So we want to integrate sine squared t dt, and we have sine a sine b is equal to all of that. Okay, let's see if we can simplify this further. Okay, to do that, let's say let a to be equals to b, yes, and that allows us to write sine a multiplied by sine b, since a is the same as b, comes sine a, and all of that is equal to cos a minus cos a plus a divided by 2. Sine a times sine a becomes sine squared a, which is equals to cos a minus a. It's just the same thing as cos of 0, and cos of 0 is equals to 1. So this becomes 1 minus a plus a, that is cos 2a, all of that divided by 2. So this can then be a very nice expression for us to play with in our equation. We'll just let this looks very much the same as what we have there, except instead of a we have t. So what we'll do, we'll say let a to be equals to t, and if a is equals to t, then our expression here will change to sine squared t is equal to 1 minus cos 2t, all of that divided by 2. This we'll then use to replace our initial expression. Therefore, integral of sine squared t dt is equal to, it's the same thing as 1 minus cos 2t divided by 2 dt. Yes, so dt okay, let me write the expression nicely. So all of this simplifies to 1 minus cos 2t over 2 dt. which is a very nice expression to work with. It's easier because we can simplify this to take out the 1 over 2 out of the integral sign, then we'll have 1 minus cos 2t dt, and all of that is equal to, it simplifies to 1 over 2 integral dt minus 1 over 2 integral cos 2t dt, and this we can integrate nicely. We know the integral of dt as I'm just bringing down 1 over 2 as the same thing as t. If we had boundaries, if we had, maybe from 0 to t, would put here from 0 to t. But since there is nothing there, we add a constant which is plus c1 minus 1 over 2 integral of cos 2t. So if we integrate cos, it becomes sine 2t, and then we divide that by the derivative of 2t. So derivative of 2t would be 2, so we divide it by 2 plus c2. So all of this simplifies to 1 over 2t minus 1 over 2 sine 2t over 2 plus c3, where c3 is equal to c1 plus c2. And then you can further simplify this to 1 over 2 t minus sine 2t over 2 plus c3. That's it for this video, and you could do this for any such type of problems. Thank you for watching. Sadly out.